Okay guys, let's move to question 1.1.3, which is into 1 minus x close open x plus 2 close less than 0. So in this case, you're dealing with inequalities. The moment you see this sign, it could be less than as it is, or greater than, or less than it's equals to, or greater than it's equals to. Then you know you're dealing with inequalities. So these are the steps to follow in dealing with inequalities. So your first step is to find your critical values, and these are the values. Your second step is to determine the shape of the graph, which could be a positive ax squared or a negative ax squared, and you get that by multiplying the x values. So in this case, you'd say negative x multiplied by x, and you get negative x squared, which will be a negative ax squared, your a being 1. So you've got a negative a value, which gives you a shape of this graph, which is a set face because your a is negative. And also, if you had a positive a, which could come from, if it was 1 plus x, you'd have x times x, which becomes x squared. So your a being 1, which is positive, you would have a positive shape because your a is positive. And your third step, that's where you give the answers. So your answer comes from your critical values, and also you need to then determine if the sign is less than or greater than or less than and equals to or greater than and equal to. So that comes from the original equation. So in this case, from the equation, we've got a less than sign. It could be greater than, it could be less than or equal to, it could be greater than or equal to, as indicated previously. So in this case, we've got a less than sign. So you'll find your answers from your critical values, and then from there you determine if you've got a less than or a greater than. So if it was a less than and equal to, then you'd either have a less than or equal to or a greater than or equal to as part of your final answer. But in this case, you can only have either less than or greater than. Okay, let's now answer the question. So our first step is to determine the critical values. So in this case, you just equate this to 0. 1 minus x is equals to 0, and your x is equals to 1. So what I did was to write x to the right side of the equal sign, and it changes a sign, and rewrite the equation such that x is equals to 1. And also you do the same for x plus 2. You equate it to 0 and you solve for x. In this case, our x is equals to minus 2. Changes from positive 2 minus 2. And next step, we determine the shape of the graph. So if you can check, you multiply negative x times x, you get negative x squared, which means your a is negative. And remember, when your a is negative, you've got a set shape. So that means your general shape of the graph is something which looks like this one. So after determining the shape of the graph, you then draw x-axis where you write your critical values. So on your x-axis, you've got -2, you've got +1, and you draw the shape of your graph. And remember, if the shape of your graph was positive, then you're going to have a shape almost the same as this. But in this case, we've got a -a. So this is how the shape of our graph looks like. And your last step is to write down the final answers. So you firstly write x, you leave a space for the sign, and you write -2. And x, you leave a space for the sign, you write 1. So you just write them as they are from the critical values, but you can't write it's equals to, because on the original equation it's a sign of inequalities. So that's why you had to leave a space for the sign. So I'm just going to show you how you determine if it's less than or if it's greater than. So to determine the sign of the inequalities, you need to know which values of x gives you a number which is less than 0 when you substitute on this function. So that's where the critical values comes in. We make use of these critical values to determine which values of x, when we substitute on this equation or function or graph, gives us value which is less than 0. So we'll then start using a number which is less than -2. It could be -3, it could be -5, -1,000, -1,000,000, or negative whatever. And then from there, we'll also test values which are between our critical values. So we can test -1, and we can also test 0. And then after, we'll then test using a +2. You can also test using any number which is greater than 1. It could be 10, could be 1,000, could be million, it could be whatever number, as long as it's greater than our critical value, which is +1. Okay, so let's first test with -5 as an example. You can use -10, you can use any number which is less than -2. So when we punch using a value which is between our critical points, we get a number which is +2. And +2, it's greater than 0. And lastly, let's try a number which is greater than 1. Any number which is a positive number and it's greater than 1. So it could be 5, it could be whatever number, as long as it's greater than 1. So when we use a number which is greater than 1, we get a negative number. So it means all the values which are greater than 1, you get a value which is less than 0. And again, when you use any number which is less than -2, you get a value which is less than 0. So in answering the question, we'll say where x is less than -2, you get a value which is less than 0. And again, where x is greater than 1, you get values which are less than 0. So if you can check, from -2 going in that direction, we get negative values which are less than 0. And also from +1 going in that direction, you get values which are negative, and those values, they are less than 0. So that's why our answer, it's x less than -2 and x is greater than 1.